You want to be caught up in all your homework spirals? Well, you should be caught up every single day. But coming back, what? I don't even know. Remove. Because what do we have right after break, cool kids?
Test.
Now, it's not right after as in Monday, but it's right after as in very quickly. Because look at your calendar. We do have a week break. Praise the Lord. We all need it. I know. But we weren't able to fit in chapter 4. But last year they were. Bummer. Let's be a little humbled and let's say, oh well, we do have break for those of you that have gotten behind to catch up, but you need to, by Monday, be ready to go for the test coming on Wednesday. Meaning, if I were you, we're starting 4.8 today. Technically, I do have us finishing and probably even starting the review on Monday, so we have like a day and a half to review. That would be a great thing. But I'm covering 4.8 at least mostly today so that you guys could even work on 4.8 and start working on the review. Now some of you are like, oh, if I do the review, I'll run out of practice. And I won't be able to practice right before the test. But pause, haven't we talked about in your shared folder, sorry, not even shared folder, your helpful links, don't I have a link to the textbook's website? And what's so cool with the textbook's website, if you guys are able to finish your entire review and homework 4.8 before you come back the week after next. Okay, you're not taking the test for anything? Okay. What are they doing in your class?
Take a test.
Okay.
Thank
you. In your textbook's website, isn't there a place where, where is it? Isn't there usually like a drop-down menu? Okay, now I'm weirded out. They changed the website. Menu? Did they make it like a smartphone or something? Oh, they did. Way to be weird. Okay, so pre and post tests. Don't you guys have like a whole sample practice test you could take when you come back? Or you can take it over break, I suppose, and do the review when you get back. Either way, it is a very smart idea not just to totally forget about all of Chapter 4. You have 2 different sets of practice multiple choice, and you have the review in your book. So I would do something over break to review. Does that mean all of break? No. Do you deserve a break? Maybe. But you get one no matter what, which is God's grace. Then coming back. Use that time well. Get some rest. Have some fun. Have some family time. Always praying for those of you that family time is not fun. Praying for grace for that as well. But take some time. Get some rest. But please, please, please don't lose sight that we have a test right after we get back. Okay? Okay? Okay. Thanks for of you that acknowledge my existence. Okay. So we're going to go ahead and check section 4.7. Color pens out. Let's grade it. Those of you that weren't ready for today, you're watching this video over break and getting it graded before you come back. True? Cool. Number 1 and 2 and 3 and 4. 1 and 2 and 3 were all notation-y ones with domains and ranges straight out of your notes. Hey, the answer should have been right there waiting for you because of what we did in class, right? Number 4 is just inverse. Number 10, final answer. The final answer, pi over 4. If you put something differently, check and see if it equals the same as pi over 4. Maybe you just picked the wrong angle. Number 16, final answer. Pi over 4 again, that's boring. Pi over 4 again. Number 40, final answer, the one right answer. Root 3 over 2. If you guys are doing this in your calculator with a cosine inverse button and getting a decimal, that's not going to cut it on the non-calculator portion of the test. You're going to have to know your unit circle forwards and backwards. I give you an angle, you give me a ratio. I give you a ratio, you give me the proper in the right interval angle. I know that's auditory and some of you aren't tracking. We'll look at it in our notes again, but just hear me when I say unit circle forwards and backwards, yeah? Okay, thanks, Colby. 52. Final answer, pi over 2. Ooh, it was like one of the weird ones in the notes. Did it just cancel out? No, because he was not legal in my interval, but he's the exact same. 7 pi over 2 has the exact same cosine as the legal one, pi over 2. Number 54, set up a little triangle. Solved with Pythagorean, the third side. Final answer for secant, 5 over 3. And they mentioned the angle was in the first quadrant, hence why it's a positive 5 over 3 and not a negative. So far, I think almost all of them have been like examples we did in the notes, right guys? Isn't that pretty much every homework? Should always have your notes close when you're doing homework. Number 66. Hey, it was one of those like Xy ones, and then we still use the Pythagorean, and then we put it all together. Go team. X over the square root of x squared plus 1. Now pause. Hold on. Let's see if we're smarter than the book. Did they give you a quadrant for the angle? You should have it written in the problem or the directions if they did. Did they give you a quadrant for the angle? If they didn't, what should technically be in front of the square root?
Plus or minus.
It shouldn't have disappeared. Were you smarter than the book? There should be a plus or minus if they did not give you a quadrant. Now, just to make sure that I'm not telling you something illegal, I'm going to quickly go to number 66. Just to make sure they didn't give you any sort of quadrant idea. Nope. You guys are smarter than the book if you kept your plus or minus. Number 78. Same thing, I think. They did not give you... Did they? They did tell you x is greater than 0, but that doesn't really help me with the quadrant. Same thing in 78. They did not tell you a quadrant, so technically that would have been a plus or minus, because you wouldn't have known for sure. Oh no, they gave you that part. I apologize, they gave you that part. If they gave you that part, you do have to stick with it. It is only positive. They gave it to you as a positive. You can't go putting in a negative of something that they gave you as a positive. I apologize. This one needs to stay the way it is. Make your triangle. When you solve, you do get just a plain old x. So our cosine is x over 6. You could have written it as adjacent over hypotenuse once you solve. That one was a little bit funny. Made you think a little bit hard, but no plus or minus on that one. What else have we got? 108. Solve for theta by taking, arctan is the same thing as what? What's that mean again, arctan? Good, same thing as tangent inverse. If you wrote tangent inverse, you're fine, that's great. Solve for theta using tangent inverse, then they give you stuff to actually plug in, and you're like, sweet, here we go. And do you guys see how it's radians or degrees? Which mode were you in? Well, that's the answer you should have. If you wrote both, cool. Overachievers, way to go. Any questions, odds or evens? You okay? All right, those of you that graded, good job. Those of you that didn't grade because you didn't have it ready, oh my goodness, catch up, but you'll be fine. Colby, as long as you catch up.
How do you know when you're supposed to put in rankings and when you're supposed to put in?
Oh, does anybody remember how I said it yesterday? Knowing that there's two different answers on the board? No.
If it tells you to do degree or radian, then do what it asks, but if not, then you can put either.
You can put either, you can put both. On the test, though, might you want to peek at the multiple choice answers if you're doing an inverse to see if maybe they're all degrees or all radians, just to know what to do first? Yeah. So if it's a multiple choice test, maybe the answers, they might give both or they might just give radians or just degrees. You just need to be able to match it. So be able to look for the degree marks or look for the non-degree marks, but otherwise, if it's like a long answer, put whatever you want, unless I say in radians or in degrees. Does that make sense?
Yeah.
Okay. Any other questions? We're okay? Right triangles aren't that scary?
No.
Unit circle we'll make sure we have mastered by after break? Good. All right, section 4.8, let's see what's going on so that those of you guys that want to not come back and be behind, I don't know if it's behind, but want to be on top of things when you come back because you're tired of feeling behind. There you go, that sound better? Section 4.8, let's get as much done as possible, and guys, to be honest, there's not really many notes to take. There's not really a lot of notes to take. There should be, there aren't a lot of notes. There are a lot of examples, but not a lot of notes.
It's the word section.
Yep. I mean, they all have words,
But this one's like
Are there gonna be some word problems?
This one's like dedicated to word.
If you think about
It was the last section. It's like applications.
No, the last one was like you thought you got it. Just kidding.
False.
It's like it builds up your confidence in time, and you never crack.
And you say English thing while you do that.
But wouldn't you rather be humbled right before the test And if you humble at the beginning, be all puffed up before the test and then be like,
I've got
oh,
to confidence in myself, and then it says like, oh, I'm gonna fail if there's any word problem. Yeah, this is not fun. It's not fun.
remember, homework is to show you. Alright,
Our weakness.
alright, yeah, homework is to show you your weaknesses.
What?
I think we should separate them.
Yeah, don't worry, these you tries after break. I just have to.
What? You can't freaking
But guys,
The other one was in a school.
you gotta think outside the box and realize there might be other group 3s out there if only you could find them.
No, we already go there.
Not great time. Where's our group? Because we're smart. So that makes because we're individual.
Alright, shush. Way to appreciate your group, but in a sense, you're also not appreciating the rest of the class, so.
The rest of the class, I appreciate.
Alright. Plus a few groups already have some strong personalities. If we spread you out, maybe some of the other groups will talk too. In hopefully mostly productive ways. Okay, so. Let's you guys talk. There's just a couple of groups that just kind of, it's cool. Maybe need a louder personality.
We need a lot of this.
This is reading about the Jello today.
No,
Yeah,
it
she
isn't.
brought Jello today. We've been bugging her since on day one. She made something that looked like Jello, and she finally brought it. I did.
Not a huge fan of Jello.
You do it at least 4 days.
She told us like this is like the worst breakfast you should
I make like this
You like
thing called
Jello?
7-layer Jello, and it's like
It's
this
just
one
Jello
flavor,
on top of
and
Jello.
then there's
Does it have like cream cheese or whipped cream or like stuff
yeah,
like that?
it's like another type of sweet jelly in between it, and then more Jello, and then more jelly like filled stuff.
There
It's
you
really
go.
good.
What's that stuff? See, plain Jello is a little rough. Plain Jello with like just
It was
canned fruit is a
what
little
she
rough.
made was like
If we start putting like creamy things in there, it's a little bit better.
it was like whipped cream and just Jello. It's like what it was. Like,
Yeah,
like
like the
it had
majority
some,
is just
it
whipped
was like it had some fancy name. She kept saying it, so we like so basically it's Jello with whipped cream in it. It's like no,
I should know that. You know.
Gelatin?
no, it's like something like what was it?
No, it's not like a French word.
Yeah,
she
it's
kept,
like
she
French.
kept saying it, and we're like, no, it's
No,
just
it's
Jello
Jello
with
with
whipped cream.
No, she knows her.
There's one point she's like, yeah, I just mixed it all up inside of it. Like, it didn't look good. To be honest, like it did not.
Alright.
Good.
Now that we've wasted like 4 minutes on Jello. So, section 4.8, applications and models. See, Kyle, we're taking it easy. Right triangle problems. Question, real quick. How are they gonna name this one in a word problem? They want you to label this angle. They're gonna call it an angle of elevation. Good. They're gonna name this one an angle of elevation.
Depressions.
Yeah.
That's me right now.
Yeah.
Angle of elevation, angle of depression. Let's see, what are my steps? Draw and label a picture if they don't give you one. And even if they do give you one, you're supposed to write the directions and problems. Still draw and label the picture. Tools! I don't know, you got Python, you got trigonometric ratios. What do I mean by that? You got SOHCAHTOA, JOHCAHTOA, right? You're welcome. Gotta have fun when you say that one. George Corey was here the other day. He was making fun of how I say JOHCAHTOA.
That's food.
He was kind of making fun of himself. He's like, the first time you said that in honor of HPrecalc, I was like, what? Anyway. Good times. Trig identities. What am I talking about?
Cosine, sine, no.
Well, what do you mean by that? Because cosine could be adjacent over hypotenuse. That's not what I'm talking about. Trig identities.
Oh, sine equals what?
That would be unit circle. I didn't actually write that down. Unit circle should be another tool. I probably should have written that. Come on, you had to table this chapter. Ooh, a table that you need to know for next Wednesday.
Oh, beta, beta. No?
Not the big letters, so that's probably good too.
Like
Not the cheater chart. Are you thinking? What, Joseph?
I forgot what they were. It's like sine squared theta plus cosine.
Yeah. Remember those ones? The trinomials and the quotients and the reciprocals?
The identity.
It should be section 4.3,
Reciprocal quotient and
4.3, I think. Double check. Is it 4.3?
Yeah.
Go team. Trig identities. So like the reciprocals. No, they're right. They're right. The reciprocal, the quotient. The non-directed talk. Yeah, shush. But otherwise, reciprocal quotient and the Pythagorean. Not as in the theorem. Wait. Why are the Pythagorean identities called the Pythagorean identities? How? This is x, y, right? What is x, y the same thing as? So couldn't I say x squared plus y squared equaling 1 is the same thing as cosine squared plus sine squared equaling 1? Whoa! It is the Pythagorean theorem. Go team. Anyway. We got the trigonometric identities from the table in section 4.3. If you want to write 4.3, that might be a good place to look. And then inverse trig functions from 4.7. You can circle forwards. Ooh, let me write that. And backwards. Forwards and backwards. Forwards and backwards. Alright, ready, set, go. Draw a picture. Oh, there isn't one. That's okay, use the words. But do not start solving until you check your picture with your groups. Do not start solving until you check your picture with your groups.
That's
Alright, once you check your picture with your groups, yes, you may have your calculators out. Most of these will not be in the circle. Go ahead and solve. It's my calculator. What mode have you better be in? Yep.
Yeah, because it's opposite of I'm trying to find that because we're trying to find the length of the shadow. This is the shadow being cast by this, but my sun is 20 degrees from the horizon.
Or like 32.
But is it?
What do you guys think? 32.970?
I agree. Yeah.
What was the picture? What do you label? 12 as the opposite of what angle? There's the sun.
Wait, what?
Wait, how does that?
Wait, how's it with the horizon?
Above the horizon.
What's the right?
What's confusing? Is the sun at the top of the statue? The sun is in the sky. The sun has some sort of position, and as it shines on the statue, it's going to cast a shadow. This is what they were looking for. How long is the shadow? So therefore, we had to set up a trigonometric ratio. So for TOA, I have an opposite, and I have an adjacent. Didn't you guys solve by, here's one way, multiplying by x and dividing by tangent?
If we don't draw the sun, we can work on.
If you just draw the triangle, you'll probably do it. Sound good?
We did change the answer if we multiply.
If you did what?
Never mind. Yeah, if we multiply this value, that's stop x.
Yeah, you can't do times 12. You have to multiply up the x and then divide. Or you could divide by 1 over 12, but then you would have 1 over x, so you would have to do the reciprocal of both sides to make it
So
work.
it's just easier just to do it together.
I think it's easier just to undo the division like we've been kind of doing all year. If there's a division, undo it when you're solving. It just makes everything simple. For those of you that don't know exactly what Andrew and I are talking about, how I solve is a little weird for some of you. You don't always have to move the number. Sometimes it's easier algebraically to move whoever the denominator is. Then, once you have x times tan of 20 equals 12, now divide by tan of 20. I don't know. As far as my mental math, that's a lot easier in my head to do. Ready, set, go. Ooh. Go, team. Thanks. Good thing is there's a picture. So get the picture down and then see what you can label that is not already labeled for you. Take some time, groups. Work together. All right, Colby. Rise above. Here we go.
That was the best.
Sinusoidal tendencies? We're saying someone's moody?
No.
Right? Someone, never mind.
Yeah, I got it.
It wasn't a joke, it was just, I was trying to figure out what you meant by sinusoidal tendencies. You're a wavefront? There are multiple triangles you can draw. What are you going to draw?
It's not drawn to scale. That's it. It says not drawn to scale.
So this is a no.
The angle.
The triangle is how far part of the town?
So if you find the angle of the first one.
You at least know what to make x, right?
Well, technically you can get all
Yeah,
three angles.
then you do this times and you gotta find this. This is
Make one town a point, make another town a point.
Oh
Aren't you trying to find this?
this flip it.
my. I literally don't.
Yeah, we can flip it, right? Yeah. This is still 10. If we flip it, then it's easy. Because then this is the 1 versus 27. This is still 10, right?
We can flip.
Opposite.
You mean
This-
35?
Is it 35? Yeah, it is 35.
He's doing 90 minus 55 to get the little angle inside that. That's one way.
I was just thinking, because if you add that and you add the angle in the middle, take that, then you can.
You can put triangles on the ground or you can put triangles in the sky. Both will work. Triangles on the ground, that works. Triangles in the sky would work too.
10 over x.
Yeah, isn't it minus 10, 28?
Here's my calculator. Do you want me to show you guys the right answer so you can see what you get? Oh, this is the right answer, not the worst.
I got 11.8.
Oh, man.
05.
Don't look.
It's kind of hard.
This is
Did I didn't have a calculator?
so you got 10,
I got it.
20,
Yeah.
and then you can cancel 55, and degree, and you subtract.
Talk it out if anybody's gotten it. Make sure your group is tracking.
Yeah, but somehow mine was negative, so you can't have negative distance. It's close. I didn't know that you have a lot of subtraction.
How are you doing?
Well, I just did.
I kind of like it in the sky. I think it's easier, but you could do the ground.
I got it. I just did it backwards.
Ow. You just put little like feet for playing.
No, look.
Oh, I'm impressed.
I want to see that point.
I do triangles with the sky. That makes sense. You could have done with the ground. With the ground, you would have to do like 90 minus each of them to get the angles. So you could do 90 minus. This one would be 35, yeah? And then this one would be 62. You could have done it with the ground. I just did it with the sky because the 55 and 28 was already given. You could have done it with the ground. Long story short, what did we know about whether it's with the sky or the ground? What did we know about the opposites? Well, it depends. I guess this one would have been adjacent. So this way, with the sky, what do we know about the opposite sides?
10.
Yeah, they're all 10. We knew the opposites. We needed to find the adjacents. So the big triangle is going to be this one. The little triangle is going to be that one. And how do we get x? Subtract. So if you think about a couple different ways of thinking about it. You think about maybe this one being like A, and this one being like B. So you could say tangent of 55 is equal to 10 over A. You would multiply up the A, divide the tangent. That's where I get this one, the smaller sign. You could have said tangent of 28 is equal to 10 over B. Multiply up the B, divide the tangent. That's where I got the bigger one. Subtract the two. That's one way of thinking about it. Once again, if you went to the ground, should you have gotten to the same answer? Yes. It just would have been a little bit different because you would have known your adjacents. You would have been missing your opposites. Which in a way might have been easier mathematically, but you would have had to do 90 minus to get there. Question? 11 flat. Did you round anything as you were plugging in? Ooh, as soon as you round, you're going to have some error.
Okay, so if it was a fill in the blank, or like it was a student.
Well, let's just do this. We're honors. You shouldn't round until the end. So if you either write down a lot of decimals, I would say a lot being like maybe 6. If you write down 6 decimals, it'll be fine. But can't you also scroll up in your calculator and steal a decimal? Or can't you plug in an expression, like plug in expressions all at once and not solve in baby steps along the way? Just be aware. Be aware. Any other questions? Wow, this is fairly painless. Usually this one takes forever. Huh?
How many more examples?
I don't know. For today? We'll have lots. Woo! Words! Alright, words! Ready, set, get a picture. Check the picture before you solve. Remember, there are very few notes that are on the exam.
550 miles an hour.
I'm like in like an hour and a half.
So wait.
Approaching, meaning you see it in the distance, and it's coming towards you. Right?
So from your point of
Not at you, but
Does it bend? Oh, it's. Oh, no, it's you guys divided by.
Wait, do you need this?
Thank you.
You assume it's 5.
it says something about 1 minute later. I think the speed and the 1 minute.
Don't tell me she's the teacher. Just like, don't tell him how to do it.
That's in here.
No,
Not everybody knows the physics. The speed cannot label a side. The speed cannot label the side, but the speed with the minute might tell you the distance it is.
Oh, you're already doing it.
The speed cannot label a side. We're talking about distance, but the speed with a minute might be able to help you figure out the distance.
Oh,
that you want. Oh, wait. Altitude is another way of saying height. Does that help?
Yeah.
How high the plane is off the ground? Not how far from you, how high off the ground. Altitude, just how high it is. Not from you. Which makes sense. When the plane flies overhead, if it's off in the distance, it's low. As it comes up, the angle goes higher.
Is it miles up?
That's how many miles it goes.
I don't, that's not my calculator.
Because if I divide it by 60, now I know how far it went in 1 minute. So then I know my height. For one of them was 29 minutes. Think about like,
I had 11.7.
if I see it now, I'm sorry, yeah, so if I divide it by 60, because he went in 1 minute. I divide it by
Dimensional analysis, great idea.
because that's in 1 hour. I'll see how far it goes in 1 minute. Do you want to go feet?
This keeps giving me
11.7, 12 hours.
It's not easy. But did you finish with the bio? Did you finish?
Oh, that's weird.
Yeah. Oh yeah. I think it can be.
You guys realize you have to like deal with an X, right?
Yeah. What?
Yeah. For the 57 you get over, because that's 1 minute.
What are you guys calling your altitude? A or X? X?
I didn't call it anything.
You guys realize you need a system of equations because there are two unknowns, true? If you haven't thought about putting a Y in, there's something else you're missing.
No. Sorry. Do it again. No, go back. Push it back. Oh, that's natural. Renzo does that whenever he sees it. Renzo will just walk up to me and grab my hand instead of popping me. No.
Alright, I finally got it. You guys want to see the chest?
Oh, what is that?
What mode are you in? Degree still, right?
Yeah.
You know, I can hear it. We're ready. We get it like I thought it would be.
3.230 miles.
Never mind.
Wait, what? Can you say that?
3.230.
Yeah, I didn't even.
I don't know how to do this.
3.230.
It's everything.
You ready? Which tangent is it? 57?
Why is it negative?
Yes, I factored out an x. I factored out an x, then I divided. I know you might not know where all of it's coming from, but is the math making sense?
Yeah.
So far, so good? How to get 550 over 60 to be the distance the plane moved in that 1 minute?
It's per minute, not per hour.
Yeah. So when at miles per hour, don't you have to do dimensional analysis by multiplying by 1 hour over 60 minutes?
Mhm.
And so in 1 minute, how many miles did it go? 550 divided by 60. But the problem is, that's not a side of the triangle. To make a side of the triangle, I need that other measurement, which I called y. Ooh, where's my y? Isn't y the adjacent of the little baby triangle?
That's a 60 degree under the 57, right?
16. That big old equation came from me having y being in two different equations.
One-to-one property.
Which came from tangent of 57 is x over y. The tangent of 16 is x over y minus, no, y plus, I apologize. Now, here's a big jump, and let's see if you guys can make it. This one, the jump shouldn't be too hard. Multiply up the y, divide the tangent. Boom, got it, right?
Mm-hmm.
What do I do on this one? Do you guys think maybe I multiplied that up? And when I multiplied this up, what did I divide? Hey, there it is. I multiplied this up. I divided tangent 16, and what did I have to do with the minus 550 over 60? I had to subtract it to the other side. I made an expression for tangent of 57. I made an expression for tangent of 16. I had to get the y by itself on both. I set both of those equal to each other. I got the x terms to one side, factored out an x, and then solve, solve, solve. Whew. Little rough, huh?
Way rough.
Very rough.
Pause. Take a second. Did you guys figure out the math for that big jump, the tangent of 16? Multiply up the denominator, divide the tangent, subtract the 550 over 60. Has anybody double checked my math? Did anybody actually plug it in to see if it's 3.230?
Yeah.
Good match.
Yeah.
Okay, what made this one hard? Not only did it have x, but it also had,
What?
and so we had to think system of equations. I solved for one variable. Why did I solve for y and not x? What do you think? What were they asking for?
The
Approximate the altitude. And who was my altitude?
X.
So I left the x's in so that at the end of the day I would have x. I could have solved for x, found y, but I would have had to go back and substitute again. There's one big idea that we're going to have to pretty much wait until after break. To solve or to talk about. This is why we need one more day. Compass bearings or bearings are kind of nasty. I'll show you the idea of them. If you've been in Boy Scouts or Girl Scouts, you might know, but besides that, probably not much of a reason unless you guys do a lot of like hiking, navigating, etc.
My friends in Eagle Scout.
That's cool. My question to you is, can you guys, we'll go ahead and take a second to write this down, but my question is, can you figure out what quadrant each of these angles are in? And what the 35, 80, and 45 is actually measuring? Bearings, used in navigation, measures according to a compass. And if you guys think navigation, compass, everything is based on due north. Why? Olden days. Why would north be so important?
So you can go to
North Star. There you go. When you're in the middle of the ocean, you can find the North Star. Then you can measure rotation or degrees from that.
What is it called? Polaris.
Sure.
Polaris.
I took astronomy once.
Polaris.
It's been a while.
Walrus.
No, not Wallace.
Or is it
Due north. So if you're talking about navigation and bearings, measuring from due north is one way of thinking about it. But now that instrumentation has gotten a little more advanced, we don't always have to go from north. Sometimes we can come from south to east or north to west, north towards east. Or we could say north of east. So originally, everything would have been from due north. Now with instrumentation and with the compass, well, now we have north, south, east, west. So you guys know what compasses are built upon, right? Magnets. But anyway, coming back. If you're dealing with a compass, you can identify north, south, east, west, so then the measuring are a little bit more advanced. But southeast, what quadrant is southeast going to be in? Fourth quadrant. A question, who's the 35? Is it from south or from east?
from north? From south.
It says south first, from south. So
Oh.
starting at south and going towards east, 35 degrees. Does that make sense?
Oh, that's not that hard.
Going from south towards east. So what's going on with the second one? What quadrant?
North, west, second.
Quadrant 2. From north going 8 degrees towards the
This is
west. Well, you're going to have to draw it in order to think of how to draw your triangles, maybe in some of the homework problems, and then figure out how to label opposites, adjacent, etc. What quadrant?
The first quadrant.
And this one's kind of easy because no matter how you draw it, isn't it going to be 45 degrees, whether it's up from east or down from west? Let's see if we're right. I think I have them hidden. Do I have them hidden? Oh, I don't have them hidden. Sad day. That's okay. We're right. It's going to be way more exciting the other way. There you go. So kiddos, with bearings, the pictures might be a little bit more complicated. We can do all the homework except maybe the bearing ones. You can then come through an example and probably kind of get it, but the bearing ones get a little bit tricky. Just a heads up. Otherwise, work on those word problems. Practice your triangle skills. Start on the review. Make sure you know your unit circle. All good things. And happy almost break. Make it through today. Who still has a test or a quiz to go?
I have a Bible test.
That's it. Only one person. Hang in there, cool kids. I'll see you later.
I leave.
These pants are too hard.
Boy, they were uniform pants, Colby. Oh gosh.